Cool. Awesome. Well, thank you for having me. Thank you for having Weidmueller in this tech talk. Weidmueller's been a provider of CODESYS compatible equipment for a long time, but I think this is the first tech talk we've presented in. So it's exciting to be here. It's exciting to participate. As for a quick introduction for myself, my name is Christopher Deloglos. I'm a product manager at Weidmueller for URS, our operating system for industrial automation and IIoT. It's exciting to be here. There's been a bunch of presentations so far, which have been great. I'm particularly excited about a lot of the CODESYS presentations with CODESYS Go, LD2, visualization, as well as CODESYS Automation Server, which is a powerful application. And there's been a lot of other great presenters, On Logic for one, Northern Dynamics, a bunch of others. They're fantastic. And so it's exciting to participate in this. Just wanted to throw a shout out to Zach. Your presentation was super interesting. I've worked with making CODESYS preambles to try and have ChatGPT generate structured CODESYS, which is the way of saying I know less than 100th of the expertise that you have, but enough to understand how significant the tool that you've developed is. So I'm hoping to get my hands on it at some point. That's really exciting. But it's also really relevant to this topic of talking about open industrial automation ecosystems. Because open ecosystems lead to open interfaces, and open interfaces lead to the ability to rapidly integrate and tie in tools like AAI and LLMs to CODESYS. And so really cool presentation. And I'm looking forward to a lot of the new presentations that are still coming. My presentation today is on the flexibility of an open industrial automation ecosystem. There's been a lot of conversations about open versus closed philosophies, obviously CODESYS being the open player, and how powerful open technologies are, especially when in an open ecosystem. This isn't a new concept. I think the CODESYS community is here and has been here because we recognize the value of open technologies. But I do want to share some thoughts specifically on the ecosystem part of that and what it means to be in the context of an open ecosystem. And then I'm going to use an application in the field, a real application made by a customer of ours to reinforce that. A quick word on making sure we're talking about the same thing here. What does open mean for an ecosystem? There's a couple different automation models that you'll see around. 5-layer automation models popular, sometimes 6, depending on how you define layer 0. But an open ecosystem means that multiple technologies, whether apps, software, or hardware, are able to collaborate and integrate to accomplish a given application. The idea of a tech stack where you summarize, hey, how do the different technologies work together, is a native topic when talking about web development or software development. But in the industrial automation word, it's a less prevalent way of thinking about it. But as we move into an open ecosystem and has more and more technologies like CODESYS are becoming or are big players, this type of thought process of great, now how do I integrate? How do I tie these together? How do I get CODESYS Automation Server to work with my MES or ERP system? Other conversations like that. The open aspect of this becomes really important. And the alternative to an open system is, of course, a closed system, which you can see on the right. I'm not saying there aren't values to a closed system. There are. Integration is an example for one. If you're an Apple user, you know how easily your iPhone integrates with your Mac. The integration factor is valuable. There's other values as well. But open technologies tend to lead to standardization of interfaces, standardization of communication, standardization of APIs. And so we're really seeing an industrial environment that enables various types of technologies to integrate and to work really well together. At a system level, what this means is it enables users to combine technologies how they need to implement their system. It gives you the flexibility to combine this. It gives you the flexibility to say, I'm going to use this remote IO, and then I'm going to use this device to run CODESYS, and then I'm going to use this as my cloud management platform, as well as to share and to distribute and to manage data easily. It's a really big deal, and it gives you flexibility in architecting your system. At the device level, this means that you have to proceed with a design philosophy oriented towards open systems. It doesn't just happen by chance. You don't just make a device and then realize one day, oh, this interfaces really well with other people's technology. It has to be intentional. In an open app ecosystem or an open technology ecosystem, you seek to enable different technologies to play. In an operating system for industrial automation, that means you try to enable various apps, various software programs to be able to work together in an ecosystem. This is what Weidmueller is doing. We have an open app ecosystem. It's rapidly growing. It's built around concepts of containerization so that you can host and manage your software however you want. But it also requires commitment from an open technology standpoint. And what I mean by that is when you have an open message, you have to show that the proof's in the pudding. You have to show that we really are giving users the capability to access the device, to configure the device, to modify the device how they need. And so in Weidmueller's case, our operating system is open. It's open for the user to go in via SSH, and you can actually interact with root permissions at the OS level for customization, however you want to do it. Ideas like this are becoming more and more prominent. There's a lot of technologies that are opening up like this, where they say, for the basic user, we want to provide the functionality that they need that's most common. But for the expert user, we really want to empower them to modify and utilize this technology as far as they want to go, really. And so we do that. We provide SDKs for interaction. CODESYS is a master of this concept with their Python interface to be able to program and automate the CODESYS environment with Python. They've been an inspiration from this aspect, and so we're trying to play that game as well. And it means embracing open technologies. And so this is why Weidmueller went with CODESYS. We see them as being the open player. And we got in the game a long time ago as the using CODESYS new licensing model. We implement the full CODESYS runtime without an OEM wrapper, which means that we're able to follow the latest CODESYS version very closely. And it also facilitates CODESYS new application-based licensing model, which is awesome because it is a cost savings for customer. It seeks to put the structure of the licensing model in favor of the users so that they can pick the smallest license possible, which we appreciate. On the right, recently Jeff presented on customizing CODESYS dialogues, which is very cool. I already have a project in mind I want to try that out with because it seems very powerful. CODESYS has a lot of really cool customization capabilities. And so in the case of Weidmueller, we added in a package for hardware configuration because CODESYS enables this type of development. And so you can drag and drop and set up your IO slices and the configuration for your IO, so on and so forth, which is cool. I'm not going to spend much time here, but just want to give a quick overview of what UOS is so that the application makes sense and what the users are doing it with makes sense. You guys are familiar with Android. We talked about iPhone for a second. iOS is same story. It's an operating system based on a Linux kernel. It's a software platform, which includes apps and APIs, and it's made for mobile devices. UOS follows a very, very similar architecture. UOS is an operating system, also based on a Linux kernel. It's a software platform. It includes apps, except instead of being a Maps app or a video app, it's automation apps. Some of them we make, some of them we don't. Some of them are open source. We have an API that's being released fourth quarter for app to app and app to hardware interaction, making that easy. And of course, instead of mobile devices, it's for automation devices and IoT. This is the power of an open ecosystem of apps. Uh, the value and the power of our automation platform is brought by the ability to rapidly integrate and combine and use various apps, partner apps, some apps that Weidmueller makes, some open source apps, as well as custom apps. Anything that you want to bring that's in the Docker container, you can deploy straight to our controller. And this leverages what we see as I don't really have a word for this. I wouldn't call them mini ecosystems, but collections of apps and technologies that are hosted and managed by third-party companies for rapid integration. Flex is one of these. You may have heard of them. They have I think, upwards of 140 different apps. And by putting the Flex app on our operating system, it in turn enables the integration of 40 plus apps that are available through Flex. Powerful technologies like integration, TeamViewer, IoT, a bunch of different types of databases. It's a cool expansion of open ecosystems as we're growing. Pardon. So to give an example of this, I want to show you a demonstration of an application in the field as it's a customer of ours is using. This application is an automated leak testing system. It was a fairly complex application. The customer had several different requirements. For those of you who are involved in the engineering process, you'll see that each of these tasks becomes pretty complicated pretty quick. You want to control and manage the testing equipment. You want to do data pre-processing of the test data. You want to archive the data. You want to relay and distribute the data. You want to do reporting of the results to end users. And then you want to do equipment labeling. And so print out and manage the labels at the end of it. In order to accomplish this, the customer combined a couple different awesome technologies. The engine and the power of this was all CODESYS. It was a great solution, provided really easy and streamlined integration. It was run on UOS as the operating system. It used Node-RED a little bit for network pivoting. This was more the customer's comfort level as they're growing. They were newer customers to CODESYS, and while you could do all of this with CODESYS, and I'd argue that it would be a little more efficient to do a lot of this in CODESYS. In the customer's case, they wanted the flexibility of an open ecosystem, which CODESYS facilitated and provided. And then they use Portainer for managing these. An app, in the sense, is really a container. And so if you want to have container management, Portainer is an app available, which facilitates that really well. I'm going to hang out here for a second to talk a little bit about the architecture of this application. An important point here is you see a lot of various interactions between different components of this solution. And so you see CODESYS running. CODESYS is doing a ton. It's interacting with the leak testing equipment. There's a Rockwell PLC somewhere over there. It was from vendor lock-in. The customer had no way to get around it, but CODESYS provided a way that they could interact with that and move this operation outside of that ecosystem. CODESYS was managing local I/O on the device. CODESYS was hosting the visualization, providing that. CODESYS was also being a data source for Node-RED, a data source for locally storing and archiving that data via CSV files. CODESYS has a great library to facilitate that. And then also pivoting data into Node-RED for the customer's other applications. And then from Node-RED, the customer was able to take that data. They were able to do some email reporting, again, something available through CODESYS if they wanted to do it there, do file transfer to network shares, do some label printing, as well as nightly email reports. And so send out emails to the customers periodically showing them the results. There's a lot of moving pieces here. And usually, if you had an application this complex with this many different moving pieces, you would expect that it would become a management challenge, that there would be so many different pieces, so many different things talking, so many ways of communicating. But in reality, um, uh, part of what an open ecosystem does is it helps different technologies to standardize on their interfaces. How do we communicate? What are the definitions? CODESYS having OPC kind of as a de facto built-in standard. It's so easy to take the data to communicate, is a bit of a pioneer in this, and it makes um, managing that and communicating that between your various apps very, very easy. So in our case, this is an application that you'd expect to take a long time, to be really, really hard, probably to have some pieces that you're getting vendor locked into. You just got to buy this from this group and you're never going to be able to get away with it. And instead, the customer ended up with a very, very flexible solution, a very flexible architecture, where they were able to implement it how they want, use the technologies that they were most comfortable with. And gradually, what we're seeing now is as the customer gets more and more comfortable, they'll adapt it, they'll expand it, they might move technologies. They're looking at consolidating more and more into CODESYS as they get more familiar with it, which is great, and where we try to encourage customers, but it's a really, really powerful solution. So what can an open ecosystem do for you? Um, Open ecosystems, they give you the flexibility to pick the right tool for the job. This is a big deal. It sounds like a simple statement, but when you have complex application requirements, being able to look at alternative technologies and figure out what is the most powerful here, what is the most powerful there, have technologies that survive by their merit, is a really, really big deal. And it means that you're not limited by proprietary technologies or closed systems. In CODESYS case, there is such a massive number of devices that host CODESYS and that are powerful by CODESYS. And so being able to pick from a plethora of hardware, a plethora of IO configurations, and so forth, while still using the same familiar CODESYS environment is fantastic. It embraces interoperability and compatibility between technologies and manufacturers in the same vein. And it accelerates technology integration. We heard this with a lot of the presentations already, where there's plugins and there's apps and there's tools for CODESYS that are so easy to integrate. There's automations that are really easy to apply because of those standardized protocols, interfaces, and APIs. It encourages open source software usage and defining and embracing industrial standards. Uh, the, the negative counterpoint that is often made about this as well. You just have everything's kind of running amok. If it's open, people are all doing their own thing. And that's not true. What we see is we see consolidation and collaboration of different technology experts getting together and saying, hey, these things tend to work really well. Let's orient around this standard. Let's use it to define our interfaces and how our technology collaborates together. And then finally, it gives you the control that we need. Open technologies encourage a model that gives users more control. It try and takes the configurability, the capabilities of the device, and give as much power as possible to the end user to be able to use them how they need to be flexible how the user needs to. As we continue to pursue open automation ecosystems, these points are critical. The closed philosophy, at the end of the day, it leads to withholding collaboration with technologies in order to try and direct customers to buy the thing that you want. Withholding features or excessive use of paywalls. Withholding integration in order to enable specific technology partners to succeed. Oftentimes withholding compatibility to lock in customers and to try and keep them on your technology rather than going to third-party technologies. What we see with CODESYS is the exact opposite, which is the open philosophy. In contrast, the open philosophy, it leads to collaboration in an open ecosystem where customers are free to develop flexible solutions. It leads to choosing cost models which are friendly to customers, like the CODESYS application-based licensing model. It leads to prioritizing integration as well as possible with other technologies. If you're in an open ecosystem, it's in your best interest to collaborate, to work with other companies, to define your interfaces so that the documentation's there for how to make your technologies work together. And to prioritize compatibility, to give customers, at the end of the day, the flexibility that they want and that they need in order to choose the technologies that they want to work with and choose how they want to work with those technologies.